going to shift gears. The first couple of webinars this year, we were taking a pretty substantial dive into mathematical reasoning, and so those of you who joined us for that, thanks so much for your participation and your questions and your feedback. So today we're going to shift over into something that is very important for students to be able to do, and that is how to read and interpret data, whether it's mathematical data or scientific data. So on behalf of the professional development team, which includes me, Daphne Atkinson, Debbie Fawcett, Bonnie Goonan, and Susan Pittman, we'd like to welcome you, and we're going to get started.
Thanks so much, Daphne. As she said, today we're going to be working with that wonderful thing called statistics. And so today we're going to explore some math and graphic literacy skills that we know are assessed on the GED science test. We're also going to work with quantitative data so that our students are better able to construct as well as interpret charts, tables, and all kinds of graphics that they will see on the science test. We're also going to talk about some strategies so that you can take these things back to the classroom and help students build their literacy skills. And of course, we're going to share resources. Like in past webinars, you are all muted right now, but as you have questions as we go through, if you will, please just type them in for us. Susan and Daphne and Debbie and I will take a look at those questions as we go, and we'll either answer them during the presentation, or we will also have an end time where we will answer the rest of the questions. So please feel free as we go through. Don't wait till the end to type in that question. We know that with
Bonnie,
as many...
Bonnie,
yes.
If there's one thing we can do, because we do have a couple questions coming in, for those of you who are looking for the handout panel, it probably should be just below the question box itself or somewhere close by. You should see a word that says handouts and it has a 3 next to it. And so that's where you can actually go in and pull all of the handouts. Another question, Bonnie, that we had coming in was, can we print the slides in the workbook later after the webinar? And as far as bringing it from during the live presentation, you can print, take those off at any time, save those to your computer. But the other thing that will happen is that there will be things going up on the GED Testing Service website. And you'll be able to access some of that at that point. But once the webinar ends, then there's not a way for you to be able to pull in at that point. So, but again, you can just download and then print those things later with no problem whatsoever. And we have
those are great questions.
Yes, and we do have one last one from a GED proctor. It says, do you need to listen, if you are only a GED proctor, do you need to listen to this presentation? Well, if you're a GED proctor, we're glad to have you with us, but this will be instructional based. So I'll leave it to you to make some decisions from there as to what you want to do. And another one who says, I don't have the PowerPoint. The PowerPoint is actually one of those PDF files. So you'll be able to pull from there. So Bonnie, that's all we have for questions right at the moment, and we'll go back and let you lead on from where you had started.
Okay, I know we have quite a few of you on board with us. So we're going to, throughout this particular presentation, ask for some responses, and you can just type in your answers. And Susan's a fast reader, okay? She's a speed reader. So she'll be able to capture some of that information. But, you know, we have been talking a lot about the graphics, etc. So there's this word that we see all the time, and I want to know, Susan, what the rest of our listeners think of when they hear the word statistics. So if I say the word statistic to you, what's the first thing that pops into your head? And if you want to quick type it in for us so we can see kind of the pull of the crowd, so to speak.
Oh my, we get mean, median, mode, we get data interpretation, we got numbers. Oh, and then here's one from Kimberly King. She says, data, it's not math, exclamation point. And then we have, and she says, I kid. Yes, Kimberly, I know that. But that is something that a lot of students would say, well, that's something very different than math that we do. From Sally, lots of difficult numbers to read. Surveys. Oh, okay, Tony. Lies, damn lies, ha, ha, ha. I think there's a quote out there, Bonnie. Isn't there something like that? And
oh, I do. I believe that's true.
Let's see what else we have. Data analysis based on past records, representing data, charts, and graphs. So we have quite the list of different items that are out there that people think of when you say that.
That's great. You know, we do see statistics, data, and math on the science test in lots of places. And so when we look at this new test, we need to realize that those questions are out there that assess and analyze statistics and data indicators. And there's also questions that address the scientific method. You know, there's that short answer out there that asks for how we're going to collect data and what's it going to do for us. We also know that on this test, there is the use of the calculator and that formula sheet. And as all of you said, there are lots of charts, tables, and graphs. We're going to tell you as we go through today that some of these skills are definitely higher order skills and would be indicative of those students who would have the kind of score that would be college career ready and college career ready with credit. However, many of these skills our students need just for that diploma. So let's go ahead and get started and talk a little bit about statistics and science. But you know, Susan, we really like some of those graph starters, correct?
Oh, absolutely. Or at least I like to give them to other people.
Oh, that's true.
Well, I mean, it's always true. You always like to see how people respond to different things. So Bonnie, you've got one here, and you know it's got all these dots on it. It's the axes are labeled. You know, we got age and we got height, and let's see what we're asking for here is who is represented by each point. So Bonnie, do we want to give people just say 30 seconds or so to take a look at that graph and see if they can come up with who's who?
Oh, maybe just a little bit of where do they start?
Well, where would you start, Bonnie?
I'd start by asking you, who's my first answer?
My first answer? Oh, I have to have Gavin.
And why would you have to use Gavin?
Well, because if I take a look at all the information that's provided, I have this whole mix of older woman, younger woman, blah, blah, blah. But I have one infant. And I know if we're talking age, then that would be low down on the scale because an infant's young. And also, an infant's not very tall. So number 7 would be Gavin.
Ah, so he's short and he's young. Well, then I look at 1 and 2 now. Is 2, I hate to say that word, but old and tall?
Well, we know that 2 is tall because it's way out there on the scale. And, you know, as I'm looking at it, though, Bonnie, I'm just not really sure if that, would that be? Because, you know what, there's something wrong with this graph, Bonnie. There's something seriously wrong with this graph. Because I really want to put the age on the other plate. I want to flip those axes.
You know, I would too, and this is a fun brain teaser for students to do, and Susan and I have used it with students, and it's real interesting because they don't have quite the issue that those of us as instructors do, but Susan's exactly right. We want to see oftentimes height, quote, go up and age go horizontally or across. It would make this graph so much easier. Now,
but you know,
never
Bonnie,
fear.
Bonnie, we have someone who said, Paula says that number 1 is the older man.
Ah, okay.
All right,
So,
and does that make sense?
well, it does, because he's really
then we've got
high up.
2
Yes, the age line
is the older woman, and she's taller than Dennis is. Okay.
Yeah.
Okay.
We have some critical
So
thinking going on out there.
there is some serious critical thinking because people are really working hard with this as I'm watching the different things that are coming in and working with this. And then let's see, we do have that agreement on Gavin. And then we have someone who said that Alice is 2, so that's correct. And they are seriously working through this, Bonnie. 5 would be a teenage boy. So look at what we have there, age, but look how tall, Errol, that teenage boy is. So you're right.
He's about as tall as Alice.
Absolutely, absolutely. Guys, I want y'all to think as you're going through all of this, what you're doing and what your brain is having to do as you work through these different pieces. Because it's, you know, this is something that Bonnie and I like to do with students especially. We like to be able to see them have to think through, and it's not always about getting the answer right the first time out, but it's really putting those critical thinking skills together so that they can see, okay, I have to make adjustments in my brain for how I'm doing this, and then I take it a piece at a time rather than, Bonnie, we've all had those students who just get overwhelmed by the whole thing. There's 7 people, there's 7 dots. It's just too much information.
That's true. Well, for those of you who are still working through it and you don't want to know the answers, don't look at the next slide, but we promise you will have it in the handout, because we're going to head on and just click in a little bit into the basics, and we want to get a little deeper into the data, so to speak. However, what Susan and I have found as we go and work with students and teachers is oftentimes our students don't know the basics. They look at graphs, but they forget the basic of a chart or a table. And so there's many ways to organize data. In fact, if I could do anything, I would make sure that my students were able to read something, such as look at that long paragraph, Susan. In fact, some of the sentences in that paragraph are a little complex.
Well, that, and then I'm seeing so many numbers.
That's true.
So many different places. And so, you know, quite honestly, I may just say, forget this. But if I can take that information and organize it in some way, that can make a difference. So by being able to go from the narrative into a table now can lead me to make some decisions about maybe using a graph to display that.
Oh, that sounds like a step-by-step process. So let's look a little further step by step, because you're saying I could take the information from text, determine what that information is, pull it out into a table, and then I could say to myself, okay, now I can put it into some type of a graphic. But how do I know which type of graph is going to be best suited for that specific type of data?
Well, I think that's the question that as instructors, we have to ask our students. We have to have them determine, based on having that table, how would they go about displaying that information? Do they recognize, do they know that, you know, moving from a table into certain things, maybe what we have is we have something where we're going to do a bar graph. Maybe we're going to do that circle graph. But those are the types of things that we have to be able to look at.
So
and
just
Bonnie,
a few questions for you to think about. Yes.
Go ahead.
We want you
That's
to
fine.
think about, do your students know how to use data tables. Can they present that data, and can they compare, contrast it, or can they even find what you're asking for? When they're looking at circle graphs, sometimes we call them pie charts, can they represent that data as values or variables? Can they see the different segments, and can they figure out proportion, part to a whole? And there again, as they look at it, can they see which ones are easier to read? These are real base skills, but our students really do need to know this before they go into that next step. You know, Susan, I think sometimes line graphs can cause the most difficulty, and when we look at different items on the item sampler, et cetera, and some of the materials, we know that it's not oftentimes just one line on a line graph. Oftentimes it's multiples. So what kinds of things do our students need to know about line graphs?
Well, there can be any number of things that they're going to do, but they need to understand, first of all, what a line graph is designed to do. They need to know that it's going to show a direction, it's going to show a trend, and they've got to be able to recognize those variables that are there. That on the x-axis, it's usually something representing time. If they look at the y-axis, it's a percentage or maybe some kind of quantity. And if they can make a prediction, they can forecast something from that. But they also need to take and pay attention to any kind of labels that are included. Just example, this particular graph now, and that's not to say that on the GED test they'd have a graph like this, but that students would be able to identify what those different lines and those colors are representing as they're going through. So you can't just miss, just kind of glance at something. You really have to study the graph itself.
Okay, we have bar graphs. Are there bar graphs on the GED test, especially science?
Oh, absolutely, we have bar graphs. And, we have another type of graph, and we'll talk about it later, that's very similar to this, but at the same time, students need to understand, like looking back to when I was thinking all those library books that we were talking about at the very beginning, how would you compare one to the other? You could do that based on having a bar graph. That's another thing. Do they understand the purpose? And also they've got scales that are sitting there on that axis. They've got something that's going to label it as a category. And, it's one thing for students to see those vertical bar graphs, but sometimes it's horizontal. And maybe students aren't quite as familiar with that. One of the things that Bonnie and I have often talked about is the fact that our students don't need to just interpret these different kinds of graphs, but they actually need to construct these. They need to have real life, contextualize it, do surveys or whatever within the classroom so that students can then display the data, and they can see who might display it in different ways. But it's about, if you can create it, then you have that understanding behind it, and then you're much better off when it comes to interpreting something later on.
As I look at this graph, Susan, I can think of a hypothesis for a scientific experiment where my students would have to determine which type of liquid was best for their plants, which type of liquid would create the maximal growth. Would it be water, juice, or soda? And I see 3 bars, so it says to me that there are multiple trials. They may have either 3 different types of plants or 3 plants of the same type, but we all know that not all plants grow exactly the same. So looking at this, I could think of a lot of GED type science questions that could be asked of this type of graphic.
Absolutely, absolutely. But Bonnie, you know what, there's more to graphs and displaying data than just doing charts, tables, and tables and graphs such as line, bar, and circle. And I think, we get really focused in because those are some of the basics that we always go through. But we should be able to look at data in a lot of different ways. There's usually more than one way to display it. So let's take a look and see and think about it in terms of your own students. how are your students doing when it comes to displaying data? Do they even, these things, they even think about them as they're going through?
Okay,
So
let's see.
why don't we give it a
I was
try?
going to say, you got it. Let's see what this group thinks. You have, gosh, we've got this package of nails, and looks like they're all different lengths. I want to know, what would be the simplest way you could go about organizing all of that data? What do you think, Susan?
Well, I think the very first thing that I would want to do within this, because I see some things are repeated, I'd really want to go from, the smallest, the shortest in this case, up to the longest nail. So I would want to put things in increasing order. So that would at least get me some kind of sense, because once my data is at least minimally organized in some way, then I would be able from there to go and work at it from different angles.
I really like your mode of thinking. We can take this one bit of data and go ahead and have students determine what else they can do with it. Because what I like to do is use one chart, one bit of data, and do lots of stuff with it so that students expand their knowledge. So,
And Bonnie, that being said, we have some people who are popping in and they said, okay, could I do a frequency table or something like stem and leaf plot, a line plot, a dot plot? We've got a number of different things that are coming in from different people who are participating today about how they would go about organizing this.
This is a great group because they are thinking the way we want our students to think. So someone talked about something called a tally table. We don't always think about a tally table, but you know what? If I wanted to determine how many nails very easily, when I look at all these numbers this way, I go, okay, there's 2 11-inch in there. Whoa, my eyes start kind of going strangely. But if I do put it in a tally table, I can very quickly see I have more 16s, I have more 21s. And boy, if I wanted a 24-inch nail, or millimeter length nail, I am not going to find it in this package. But look at how much clearer this is than if I just go ahead and arrange them in order. Now, did you say somebody said a line plot?
Mm-hmm.
We just happen to have one.
I'm not surprised.
And it looks something like this.
We have a line plot, but Bonnie, we could get a little creative and we could actually have a pictograph.
Okay, how's a pictograph different than a line plot?
Well, I just have to draw some little nails.
And it does work. It works very, very well. 2 different ways of displaying data. Actually, we have a number of ways already of displaying data. But I think somebody else said they could use a frequency table.
Yes, a frequency table, looking at those things from that direction as well. So we have, and this would give us a great opportunity also to work with students on those inequality things like 10 less than the length or less than or greater or equal to or less than the other. I mean, there are different things that we could do in setting this up. And we could do it in the chart like you have or spread it out. Either way would work.
That really hits a lot of skills, Susan.
It does. And I think that's the thing that students need to see is that there are so many different ways to represent things. And so maybe they're not thinking about that one that they saw on a worksheet or in a book, but something else pops in. They have options in order to be able to organize that data, which is going to be very helpful to them because as we look to the next slide, what we're going to see is if we have that frequency, then we can put together that thing that many students confuse with a bar graph, and that's called a histogram. So a histogram would work, but notice how we've had to organize the data to get to this point where we can put that together.
I really like this histogram, though. It really is clear, and if my students have gone through these different types of displays, then this is really going to make sense to them because it does show frequency and range. So I really like that one. I just can't imagine how my students would have responded to the word histogram if they faced it on a test and I'd never taught what that did. You know, we hear a lot about box plots. I think there's another name for them, isn't there?
Box and whiskers.
Ah, this is one of those videos that we're going to apologize up front. Trying to do a video, a streaming video on a webinar is probably frustrating to you as the listener or the viewer, just because it's not as flowing as we would like. But if you're going to teach about box plots, what we're going to ask you to do is please download this video or just click it, because I think what you're going to find is for the first time, your students are going to say, aha, that makes sense. In fact, it's a great video for all of us before we teach the process to just get our minds wrapped around, aha, this is what all of those terms mean, and it's done in a real world situation. Susan and I have seen a lot of videos on box plots, and we both think this is one of the best, one of the most clear, short, sweet, but to the point.
Well,
but you know,
we have, Bonnie, we have Diane Kelly who's out there who says, in all caps, I love this video. Use it all the time. So it's good to hear from other people that, yes, they like this particular one as well. But I agree with you, Bonnie. It is something that I think students can walk right away from it, and they have that understanding. And yes, we do realize that you can't type, that you can't click on it from here. But what I'll do is I'll put that link on into the chat box itself so that you can copy that and then go back and view it later on.
Okay, Susan, we had that box of nails, okay?
Mm-hmm.
I'm wondering if I could create a box plot with that, because you know, sometimes box plots can be very useful because it tells us a whole lot more information than if we just find out that it's the mean of something. You know, I've often wondered if the average wage is this, why so many people may make below this, or if the average price of a house is this, how come? Because sometimes mean just doesn't give us the kind of data that we really need. So what I can do to create a box plot is I can arrange that data in order, which is what we've done here, and I can divide it into quarters, which is my first step. Finding the median first, the middle, and then finding the middle value of that lower quartile and upper quartile, and then those extremes, those things that go out. Isn't that pretty? Now I have it divided into fourths.
Well, and notice what you had first, though, Bonnie. You had to go back in. Very first thing is that you had to use that information you had developed first, which was actually putting things in order. So there's different steps in the process, but our students, they know things like median. And so when they're thinking that a box plot is so difficult, it's really not if you just know the rules to it.
So I know median, the middle number, quarter, even if I don't know quartile. So that should be an easy fit. And then we all know that there are extremes, especially if we have younger folks in our classroom. Sometimes they do go for extremes. Remember, I have grandkids that age. Okay, so with these lovely nails, I can now go ahead and look how they are going to be plotted on that number line, and I can draw a box and connect it to the extreme values. And guess what? I have this box and whisker plot that really does give me a good idea of what I have in that box of nails. A great way to go from very what do we want to say? Data which is not aggregated all over the place to all different types of graphics with just one idea. A great way to teach a lesson. But we also have some other things, don't we? We have mean and median and mode, and we have range and mean absolute deviation and standard deviation. And before everybody gets upset about, oh my goodness, my students need to know all of that. Well, they need a basic understanding, but we all know that mean absolute deviation and standard deviation are a little higher skills. But if I could get my students to know those other four very well and to understand what mean absolute deviation and standard deviation are, then I think all of our students would do much better. But Susan, do we really see this stuff on the GED test?
Well, we do. And to just prove that point, we actually have one of the questions that was set up for the item sampler itself. And so if we take a look at this, what we're doing is that they're looking at the average bone density. So average is just another word for?
Mean.
Yes, it is. So students need to know those things, but take a look. What are they doing? They're having to gather the information from the table itself, and then they've got to do those calculations. So yes, they are using that type of thing. So as we're going through, I think that that's one of the things that we need to be aware of, which is another reason to do a little plug for go back and look at the item sampler, especially if it's been a while since you've done so. And if you have students who are still struggling, or maybe they've just come into your particular program and they're working kind of a little lower level in math, it doesn't get much better than this one video that we have, which deals with mean, median, and mode. There's only one problem. It's that it will get stuck in your head after you hear it a couple of times. But that's okay for students because we want that to be stuck there. So that they can actually go in and they're going to remember what these things are. But it's very basic and a song about mean, median, and mode.
So when analyzing data, we want our students to be able to ask themselves some questions as they look at things, because remember, it's a really important part of scientific investigation. We want them to be able to ask themselves, do they see a pattern? We want them to be able to interpret what that graph tells them specifically. And also, who could use that information and how could they use it? We also want our students to be able to determine why a certain graphic is used. In fact, what you may want to do sometime is give your students a very easy thing to do. Susan and I have done something such as just checking their heartbeat in a sitting position, a standing position, a walking in place, and then a jogging in the room, where they check their heart rate 4 times, and then they select a graphic to display it. I guarantee you that it's amazing what graphs sometimes students try to use and how they try to fit that information into a graph that it was not meant for. But it's really an eye-opener, not only to them, but to us as instructors, so that we can determine where do we need to go back and figure out what they missed when they looked at different types of graphs. So we've covered the basics, and these really are basics. But there's some other ones that students may see on the test, but they're also seen in real-world situations. And scatter plots are very, very common. We see scatter plots all the time. In fact, they are similar to line graphs. They do have horizontal and vertical axes. There's usually 2 sets of data that are plotted as ordered pairs, and we all know that our students have had to deal with that type of graphing for a long time. And they show how much one variable is affected by the other. It's a correlation. So these types of things our students need to be able to read and read well. Here it's a comparison. Wow, of tree rings. I'm wondering, does anybody really care? And I'm sure they do, because there's a reason for it in science. But besides just knowing those basics, when we're teaching scatter plots, our students also need to know the vocabulary of scatter plots. And these are the basics. My goodness, Susan, these are quite the basics, aren't they? Bivariate data, independent
Well,
variable, dependent variable.
some of these things should be very basic, but sometimes that bivariate data gets people thrown. But at the same time, these are some keywords that we need to make sure that our students understand. And so when we're looking at bivariate data, we're looking at two different variables that are coming into play. And so we have independent variable that we worked with in math. We do it as well when we're working with a hypothesis and doing an experiment. Line of best fit, that's kind of a different term that maybe students don't know, but we'll talk a little more about that. But we have another thing. In looking at scatter plots, we've got to look at correlation. And then there's this other thing called causation. Is this thing causing something else? So if we take a look at this particular one, what we've started out with here is looking at the ice cream sales compared to the temperature that day. Or something like the traffic accidents along with the weather on a particular day. That we're looking at two different variables there to determine, hey, does it really, if the temperature goes up, do we have greater ice cream sales? Oh, we'd have to just look at the data and determine. But see, those are real life instances, Bonnie, that I think sometimes students need to see, as opposed to just having something that doesn't quite make sense to them as they're going through.
You're right. I would start with something like that before I went into something like the Old Faithful eruptions and looked at this scatter plot and went, oh my goodness, what am I looking at? Except it looks like we have red dots and we have dots that just have a red outline. They look pinkish to me. I'm not sure I could read anything with that yet.
Well, and that's the case, but as we take a look at it, we'd have to make sure that, we understood correlation. And that's how, really what we're talking about there is that measurement, the relationship between two different things. And also, it tells us that the two variables are related, but that doesn't necessarily say one caused the other. But then we have to understand causation. And that's like, we've been doing this forever, cause and effect. But now we're moving it into a little bit different scenario and working with the data. And it tells us when something happens, something else will also happen. So those are the kinds of things that we're trying to help our students understand as they're exploring the data that's out there. So having said that, why don't we take a look and let's see if we can make some sense of that. And especially looking at correlation.
Yeah. Okay. You said we have correlations. And, I think I've seen some of this stuff on the test. We've said that scatter plots are similar to line graphs. In fact, they have those nice horizontal and they have vertical axes. And so this one, we've plotted a lot of data here. And it looks like, one variable is affected by another. And there's this relationship that you told me about called the correlation. So as I look at this data, I could draw a line from that first one. And it looks like I've got a sign of legibility, the distance in feet, and I have the driver's age. And I have a line, and that line hits into basically the line of best fit. So tell me, Susan, what kind of a correlation do I have? I just see that I have a line there.
Well, you do, but what you're seeing is something called a negative correlation. And what's happening here is we actually have that the younger the driver, the greater the legibility in terms of the distance. So X, as it goes up, Y goes down. So that's something you see. As we're over here at like 85, we're not seeing those signs quite as well as we did at 15. Just a fact.
Yeah, I think I've seen questions that have asked whether it's a negative correlation or a positive correlation. Okay, then let me take a look at this next one. It says there's something the size of carrots and the price. So when I draw my line of best fit, what am I seeing here then?
Well, in this particular case, what you see is that on both of those axes, as the things go up, you can see the line of best fit coming in. So if we have X going up as well as Y, we have a positive correlation. And to think, take a look at those two that we've already done here. The negative correlation, it goes from the top down to the bottom. On a positive, you're going from the bottom up to the top. So as we're looking at things and you see, and think about it, if you were going to buy maybe a small sapphire or something, and you saw that the smaller the sapphire, the smaller the price. But then as you get into larger stones, larger price. So positive correlation. But
okay, this one, I was going to say, look at this one. I can draw here, and I can draw here, and I can probably draw 1,000,001 other places because I can't figure where to put that line.
Well, and that's because if you think in terms of it, there's no correlation between height and diameter. So what's happened is we have, I think someone at one point said, oh, it's kind of like having the measles. You just got these dots everywhere. And so what we do is we have these dots because here we have something that's 75 inches or feet, and you can see that diameter-wise, it could be 10, it could be 15, it could be higher, it could be, there's no way to make sense of it. There is no correlation between these.
Okay, so do my students really need to know what these types of graphs look like to be successful on the science test?
Well, I would definitely, if you go back and you think about the one where we had the tree rings and we had the radioactive isotopes, that was something that was a scatter plot, and it had a correlation as we looked at that. So yes, this would be something that our students would want to see. But Bonnie, I think of it beyond that. As we go into the workforce and we have more and more students who do that, what we find is that, data's everywhere. So it's not just a matter of something that's on the test. This is something that they could encounter if they're working maybe with a given company and they're looking at how sales are going over a period of time. And are they seeing that there's a negative correlation when you have these types of products coming in versus there's a positive correlation here with more people or younger people buying certain things. So, I mean, we are going to end up with seeing data in lots of different ways. So I certainly wouldn't just say, this is just a test thing.
Okay, so my students really do need to know these things, and if I can take them into real world situations, then it may be just a little bit easier. But it doesn't always have to be a scatter plot either, correct? I mean, I can use lots of different types of graphics to show causation.
Well, you could do that, but there's kind of an interesting thing going on here with how many variables do you have here, Bonnie?
Well, I think there's a number of them because one thing causes another. So I can say with this chart, there's an increase in the number of calories burned when the intensity of exercise increases. But you know what? I also can have an increased heart rate because I've ran really hard or I've burned a lot of calories. Now, I'm not so sure we're going to see this complex, but they do occur in life,
They may occur in life, but I think we need to get our students focused on the X and the Y axis first before we start throwing another thing in there. But that's not to say that students aren't going to encounter things at different points. So just make sure, let's make sure that as we're going through that our students are able to do those types of things. And we have a lot of questions, Bonnie, that have been coming in about the one with the song and the different URLs, and I have posted those into the chat, and hopefully I have typed them in correctly. But so for those of you who are out there wondering, where can I get that? Because I can't click on the link on my screen now. Everything is in the chat box itself.
Marvelous. Okay, just a couple cutesy. Correlation does not always imply causation, and I like some of these little things. It's important to remember that correlation does not imply causation. Besides, we all know it was Brian. Or everybody who went to the moon has eaten chicken. Good grief. Chicken makes you go to the moon.
Oh,
believe it or not.
Is that all you have to do?
Well, sometimes it hits home a little bit because those two words can be a little difficult to understand. So again, our students do need to understand that correlation doesn't always imply causation. Right. Couple more words. And the vocabulary of graphics, statistics, etc., can be a little daunting. But these two aren't too bad because I think most of our students do need to know, but they do know what a cluster is. You know, it's stuff that's kind of all put together. And then outliers, something that lies outside. So this really looks like a good graphic to show that. So lots of data points in a very small area, a cluster, but then sometimes there's just something that's way out there. You know, when I look at the number of medals that Phelps won, he was definitely an outlier for the Olympic Games.
Absolutely.
But that makes sense to me, and if our students can do some of that, it will make sense to them too. Can you see any outliers here, Susan?
Well, it looks like I have years of education, and so I have a couple that are not quite within the range. They're outside the range of it, like the one with looks like 12 years of education is up at $100,000 versus where we're seeing most people within that. As I look on up into some of the other ones in the range, I may see some as well that are just slightly out of the range, doesn't look like the Olympic Games and the medals won, but still they're not staying within that same range as you're moving through.
Okay, how about this one?
Oh, wow. I've got a 12-year-old who's I have a 12-year-old who is 5'10". Yes, and that is definitely an outlier. You can see that you've got this line of best fit going through here, and this particular boy is just way outside the range.
You know, I wonder what would have happened if they had charted foot size, since my one grandson was a size 14 at about that age for shoes. Anyway, we've covered a lot of line graphs because you do see a lot of that are made up of line graphs just because of the way they're doing. And here again, our students need to see both the straight lines as well as curved lines, because there again, if they're not seeing different types of graphs, they're going to look at the test and go, my teacher didn't teach me that. But more importantly, these would be questions that they may be able to interpret the graph very well if they just realize, yep, it's just another line graph and I know how to read it. So as you're doing that, again, give them lots of different types of graphs. But you know, one of the things I do know they have to do sometimes is sometimes they have to predict based upon graphs. Am I correct?
Oh, that's true. That's absolutely true. So you could make some predictions here when you take a look at this particular type of information where we want to have a line of best fit, and from there we want to be able to predict how many tornadoes may be reported in the United States in 2020 if that trend continues. So as we're going through, then students could make a prediction as they're looking at this as to where that would possibly be. And notice too, Bonnie, there's one little dot up there that it doesn't quite run through that one. That's kind of one of those outlier years as we're looking
well, and
at
I've got one that's really low from about 1956 too.
Mm-hmm.
Yeah,
but again,
yeah. So outliers.
Using that line of best fit in moving through there and being able to then use those scales to make that determination as far as the trend would go.
Okay, we have done lots of different types of graphics. We're going to cover one more with you. And what we're going to tell you about this next one is that we do see it in the PLDs. It is something that can be on the GED test. It's called a phase diagram. And with phase diagrams, oftentimes they are about big ideas. And one of the common phase diagrams out there talks with the states of matter. Okay, so it really deals with that theory of matter and how things can go from a solid to liquid, gas to plasma. So although you may not have a whole lot of phase diagrams on the test, if students get faced with one, they just need to basically know it's another type of graphic. Again, higher level skill, but definitely is a part of the assessment tool. So what does a phase diagram look like? What we've done here is we've taken a phase diagram or a couple different ways that it may be pictured. And there are a number of ways. This is a very simplistic way, but this type of a graphic is also really good to teach students a little bit about content of the states of matter. And again, we call it that kinetic theory of matter. But we see phase diagrams in chemistry, engineering, etc., but we also see them here in the area of physics. So one big idea, but different ways, again, to see it. Just realize it's a type of roadmap. It depicts the effect of something. So this depicts what pressure and temperature have to do with matter. I'll be the first one to tell you, Susan, this is not something that I taught in my GED classroom. I may teach it today, but I did not teach it in the past. Even though both of us have used that graphic before, but it was more to teach content instead of how to interpret a graph.
Correct. And I think that's the thing, is that basically as we're going through, we want to take a look at this from, I think, Bonnie, two different angles. Yes, we have this graphic here, but the underlying concepts behind this is what happens, you know, to say water, if you change temperature, what happens, you know, over a period of time, and that students understand, you know, some of those basics within their evaporation and condensation. I mean, those are the kinds of things that we really want our students to have an understanding. And then when they see this in a graphic, it's more of a, aha, okay, I know something about this, and then can interpret from there.
Very definitely. So as we put this in, again, just giving you a few tips on interpreting a phase diagram, that type of a diagram. I'd be interested in knowing, Susan, has anyone who's with us right now taught phase diagrams in their GED classroom?
Okay, I'm not seeing anything right at the moment. Nope. Actually, that is the answer. That is the answer that's coming in from everyone.
Yeah.
And let's see. There is a similar phase diagram. I've got this from Nicole, who says in the Essentials program.
Yes. And again, that's why we're letting you know that, to me, you know, at this point in teaching students, it is an important type of graphic. I do believe that knowing things like the states of matter and that rationale will help them out more, so that when they're reading this, they'll say, ah, yes, I understand that. In fact, one of the resources that we've just found recently, and if you've not gone out to University of Colorado. They have these wonderful simulations, and one of them is on the states of matter, but they have simulations that go everything from biology to physics to chemistry to things of math. They are free, they are extremely interactive. You can do them online or you can download them. But the one that deals with states of matter really is a good interactive for the GED classroom. Very quality materials. In fact, they just recently won an award for the level of excellence that they provide through, they call them FETs, but through these interactive simulations. So just a few things on that to get you thinking as far as phase diagrams. So Susan, we've talked a lot about a lot of different graphics, but never fear, because scientific design investigation is so important in the science curriculum. We want to make sure that you have a few extra different types of resources for use in your classroom, because there are a lot of things out there that are free, and free. And that's exactly what Susan and I like. You have in your workbook a number of them, but I will tell you that all of the ones that we're going to talk about here are in your workbook, so you don't need to worry about, oh gosh, I need to make sure I save this page or this page. They are all in the workbook. But let's just talk very briefly about what kinds of things are here, and then we'll have time for questions. Unless, Susan, are you seeing any questions we need to answer right now?
Not any questions per se, but one of the things I think was important that someone responded just a minute ago about the phase diagram was the comment that there's too much information there in those phase diagrams for very little return. Yes. And I think that's important to keep in mind too, that you might see, big quotes, might see a phase diagram on a version of the test. And so again, we have so much to work with students. I think we need to make sure we really focus our time to get the most out of it. And so that was a good point from one of our participants here.
Excellent. So just a few things, because there are such excellent resources out there. If you've been with Susan and me before, we love the Annenberg Learner. And there is a great site called Data Analysis, Statistics, and Probability. Do not get put off that it says learning math, because the information is the information. And what I love about this particular site is it's good to have ideas for students from it, but it's also an excellent resource for us as instructors when we just need to go back and say, just need that little bit of refresher. If you've never gone out to the National Science Digital Library, again, it is free. The lesson plans are amazing. You may say, I need a lesson plan because I just don't have enough stuff, because I need to teach this big idea, such as states of matter. I need to teach that big idea. I don't have the time to do everything I want to do. These are excellent lesson plans and more. Also from that, there's a whole section on using data in the classroom, so that you have all kinds of lesson plans that are aligned with science information, aligned with scientific investigation. And I'll be the first to tell you, a couple of those lesson plans implemented will teach your students so much about how to use data in science.
Absolutely.
We did put in a couple of the things for phase diagrams, and the reason, as Susan said, is not because there are a lot of them. There may not be any on a test of attitudes in the field. So if you have a real need to take a look further, these 3 sites will give you more than what you need to know. But as Susan said, remember, phase diagrams are not on every test. And if they are, it would be a minimal question, or one question probably. I don't know about you, Susan, but I loved games. And so we have some very creative folks out there. The Great Graph Math game is wonderful. It comes from NASA. And so you can see that it's about biomes and graphing, takes it to the real world. And there again, just a couple things like that can really be good skill and drill for your students. Also applying graphing to a real world story. Short stories, students have to graph towards or graph what they've been given. Great information. Susan, we've been using the Create a Graph for a long, long time.
Oh, it's wonderful.
It is.
I love it.
It's very
basic.
basic.
It because, you know,
yes.
It is very basic, but at the same time, it can add so much to what you're doing to be able to go in and create those graphs yourself.
Oh, definitely. And same way with now, don't be put off that the next one says it's a middle school portal. It really does cover the types of things that we need to have students learn. As we said, we know that none of us have nearly enough time, and many of us may not have been science teachers in a past life. So having lesson plans that are right there for us is so, so useful. This comes out of, you know, life sciences and the lesson plans. There's graphing ones. They have really a neat one that they graph and built upon the senses. So it is a biology type of lesson plan. Everything you need to deliver the lesson plan as far as information, resources, etc., is right there. These are very well done. Something a little newer that Susan and I found not too long ago. And yes, there's even more. We know that by the time you're done, you'll say, where do I start? Well, we hope that we pique your interest with at least something that you say, whoa, I like this. And these are really aligned much more towards science than just quote math. But the Science Net Links, great site. Again, what's in a graph? Dealing with science. Master Teacher Project. Are all graphs created equal? Sounds like social studies, Susan, but I don't think it was.
No, but you know, as you said, there's so many different things that are there, but I think we're going to have a lot of different questions coming in as we go through. But I want to, Bonnie has pulled up one here called Yummy Math, and they have an incredible number of different lessons that are there. Bonnie has highlighted a couple of them. Considering we just had a total solar eclipse, that's an excellent one to go at. But you know, so many different things, and so don't think sometimes that the math areas that we have don't have something that includes science. So you know, keep those kinds of things in mind.
And last but not least, if you want something that starts at the experimental stage, these lesson plans are great. They come out of, you know, a couple different sites here. Take a challenge. Does drinking soda affect your health? Again, helps. It starts with the scientific investigation and it leads into graphics. The same thing with analyzing, interpreting data. Does it sink or float? Again, a lesson plan that starts at the investigative design stage and then moves towards graphics. Now, Susan and I would never expect, because we sure wouldn't have either, that you would go back and say, okay, there's all these lesson plans on data. How many do I use? What do I use? Take a look at them and select a couple. Digging deeper into data, into scientific investigation is much more important than trying to teach so many of them. So go ahead and teach one in depth about graphing, and then teach one in depth where they start with the scientific investigation and they move toward to displaying the data. You'll learn much more and you will feel like it's something that, you know, you're very pleased because it got accomplished well. So Susan, that's lots of resources. And you said we had a number of questions. So
well, we do have a number of things. Could you pull up the workbook, because there have been some questions on that. And yes, several of you have brought up the fact that the workbook only has 18 pages, but yet there was a reference on one of the slides to page 25. And that's just an editing issue on our part. So if you will take a look, Bonnie's going to open this up and we'll just go quickly through and we'll show you what would have been on page 25, on 25 of a larger workbook. But included in this is, I think it always pays for us to go back and pay attention to the science practices. You know, yes, those are nice little things sitting out there, but if you take a look at that and think about what all we just did today, how much that could be impacted if we look back to those science practices. Now, another thing that we've included in there is that you have the graphic starter that we did, so you could use that with students. We also had the representing data, and you have the one that we started with. This is what would have been on page 25, and it has the phase diagram. So hopefully that helps. So this is actually page 6. So we apologize for that. This is something that I think would be very useful for students in your class. Page 7 and 8 includes all these different types of graphs, what they do, an example of each, but what a great resource to give to students as they're working with different things.
And all of you do have these as one of the handouts, so just know that you have access to this after the webinar or, of course, during.
Yes, and keep in mind that you are going to want to, all you have to do is click on the PDF file. It will open up, you print it out, and it has all this information. Bonnie has another one here, which is a great question to go with students. Will that vaccine make a difference? And it's about helping students go through and understand, okay, what is a control group? What's an experimental group? Sometimes we don't ask some of the most basics as we're moving through. And then I love this. This is wonderful. And Bonnie has shared this on numerous occasions, but what a great lesson plan that you can do to put together the scientific method and get all that data into it. And it is a lot of fun. Students really enjoy it, and we know that teachers do because they have a lot of fun with it as well. And then you were asking the question, as I pulled those up, where are all those resources? Well, if you look at that pages 17 and 18, Bonnie has included for you all of the different resources that she just went through on the different slides.
And more.
And more. There are more here, but at the same time, this will give you those especially, because we wanted to make sure you had access to those. And Bonnie, we keep having questions about where do I get the book displayed? If you will look on your dashboard on the right-hand side of your computer, you're going to see that it has a little box that's called Handouts, and it has the word 3 next to it. If you just open up that line, you'll see those, there's actually 3 files in there. All you have to do is click on it, and then you can save it and print it out.
Okay, then let's open it up to any other questions that we may have.
I have one here, and it says, we have, let's say you were teaching a fast-track GED program and it had about 2 weeks to help someone get ready for the test. How would you structure your class times? And for the fast-track question, 2 weeks to help someone get ready for the science test. So not for the whole test, but for the science test. And so within this, Bonnie, wouldn't you think that the best way to kind of approach this is to look at the focusing themes first, and then try to approach it within those thematic lessons? And I will tell you, and this is from Stephen Smith, who has given us some great ideas on many different things. Stephen is out of Appalachian State. The lesson plan that Bonnie included within the workbook does cover a lot of the things. We need to make sure in science that students really do understand scientific inquiry. And so being able to do some some experiments, being able to then graph the results, do their hypothesis, the whole thing, can have a lot of payback for you as you're going through working with students. What else would you say, Bonnie?
I definitely agree with you. If you can do a couple thematic lessons, and within those thematic lessons, make sure that they know how to read science text, because science reads very differently. So they need a little bit of time in reading different science articles. From there, again, 1 or 2 lessons that incorporate graphics. And then last but not least, make sure that they are taught how to write the short answers. Those short answers are each worth 3 points. If you've taught scientific investigation, how to conduct an experiment, and they've had the chance to do one, such as the M&M's lesson plan, then it should be real easy for them to get a couple points off of that short answer. If you've done some items in reading materials that deal, again, with some of those focusing themes, things like energy, things like infectious diseases, then they should be able to understand relationships. Perfect example would be, what's the difference, between the cold and a flu? Those kinds of things where there's a relationship, there's also something that's not working together. So, a couple thematic lessons on the focusing themes, at least 1 lesson on graphic literacy, something on close reading of science text, and again, in that fast-paced world, probably something on how to write short answers, which can be, of course, incorporated into the close reading. And that's probably all you will have time for, but will give you much more, your students will have much more information than if they just read a chapter of the book, answer a couple questions, a chapter in a book, answer a couple questions, and off they go. They can use that definitely as homework.
And we do have a question, and I'll have to turn this, I think, to Debbie Fawcett, or to Daphne One, about an upcoming GED Roadshow, and whether or not the October 4th, which is the next Tuesday for teachers, if that's going to impact any other PD that's out there.
Hey, this is Debbie. Can you hear me?
Yes.
Okay. Yes, we will have to take a look at the October 4th. I can tell you right now that on October 4th,
October 24th.
Oh, October 24th. No, October 24th will not be affected. October 24th perfect. Will not be affected. Okay.
Great. Thank you.
And for those asking, I'm sure that's somebody from California who is aware that we'll be doing road shows. We should get the information out very quickly, but I will tell you the Southern Roadshow will be, Southern California Roadshow will be the week, it'll be October 3, 4, 5, 6, and the Northern California will be October 11, 12, and 13. So we're good for the 24th.
Fantastic. Thank you. Bonnie, would it be possible for you to go out to the GED Testing Service website very quickly, because we have a lot of people who want to know about accessing the recordings after this is over. And so Bonnie is going to go out and she's going to open up that. And Daphne, I think I heard your voice.
Yes, I was just going to, actually, it's perfect timing to go out and take a look at the webinar archive, that anyone who wants to access this webinar and any of the others that we've done in the last 2 years, you can access the recordings and also download the material. And I just wanted to make sure we reminded people of that.
Okay, so at this point, you should be seeing the GED Testing Service website, and Bonnie is going up under For Educators, and she comes down to professional development, or there's webinars there as well. So she clicks on webinars.
Ta-da!
And just give it a moment, and there are all the different, there's the archive. So as Daphne had just said, you can download the slides, you can download the workbook, you can watch the tips and resources webinar itself, and then also you'll notice there is a certificate of completion that you can have once you've watched the webinar. So Daphne, if I remember right, these should be up maybe sometime next week. Is that correct?
That is correct. If
Okay.
not sooner.
If not sooner. So if you don't, you know, you can kind of keep watching for the one that we just did today, so you can go back in and take a look at that or pull down any of the materials. But at the latest, it should be there next week. And let's see if we have another question here.
I know we had questions about graphics on different parts or different tests, and yes, there are graphics on the math test. There's different types of graphics on social studies, and of course graphics on science. There are some differences in some of the areas because, of course, social studies, we may see an editorial, cartoon, etc. But what we teach for graphs is going to transfer from one subject area to the other. So those skills are very transferable. And as they look at the line of best fit, yes, we are talking, is there a correlation when we're looking at those variables, a positive and negative, or no correlation at all? Okay, Susan, some more.
Catherine Ladd has made a very important point, is that when it comes to science content, that some of the students may be quite far removed from having been in school. However, they can understand a lot of these big ideas if it's relevant to their own lives. And one of the things, Bonnie, that you mentioned was, you know, like working with infectious diseases or something along those lines, where students can understand from that angle. And I think, you know, just like with the playing with the M&Ms, and I say playing with, it is a really neat experiment that you can do within here. But at the same time, you know, it's something that students can relate to and understand, especially as you do the chemistry part of that. So, Catherine, good point, that try to make it relevant. And I think we had one other question. How do we check to see if there will be a road show in our area? And Daphne and Debbie, I'll ask you this question. Is there somewhere online or maybe in session or somewhere that they would find out about upcoming road shows in their states?
Well, I tell you what, we are, as of last night, I was still confirming the final location. If anybody would like to email me, I'm happy to tell you the dates that we have. We will be announcing it on those in sessions. We will send it out. Every one of you who registered for this, who are in a California address, will get the email announcing it as soon as we have the flyer prepared for marketing and the registration ready. And in addition, I will send out an email blast to the CCAE network in California. So thank you for asking, those of you in California.
And we have a comment from Jane Perini, who says, first of all, that this was very helpful and well done as always, and that she, like the rest of us, would like to offer their thoughts and prayers to our colleagues that are in Texas. And we do know that we need to keep them in our thoughts as they are entering a really, really challenging time beyond just what they've already been through, but such a long way to go from there. So, Jean, thank you for that reminder to make sure that everyone knows that.
And, you know, I just want to clarify that many of the graphics that we used in this presentation are not GED graphics. They are indicative of some of the types, but there again, we do not have access, nor would we want it, to the operational test. But having said that, I do want to make sure that everybody understands that the one graphic with the 3 different variables, I have not seen anything that says those will be on the GED test. However, it's just kind of a word to the wise when students come up and say, but what's this? That you're aware those are out there, even though they will not be assessed.
And if you want to go back and take a look at some of the things that will be assessed, you know, you can always look at the assessment targets. There's so many different things that are available on that GED Testing Service website to let you take a little bit deeper dive into some of those areas. But we always kind of give the caveat too, is remember that there's a lot of content out there, but it can't all be assessed on one test. So again, you know, we're focusing here to make sure students are building those skills as they go through.
And one last comment that someone brought forth is sometimes we have those of you who are sharing a computer as you're listening to this, so you did not get registered, but you want to be registered. I'll turn that over to Daphne and Debbie. How would they register for this workshop or show that they have attended this webinar so that they can get a certificate?
I'm going to suggest that those people, I'm going to suggest that this is Daphne, I'm going to suggest that those people send us an email at communications@gedtestingservice.com.
Okay, and that will be the last slide that we'll go to in just a second, or actually I can go to it here while we're talking about, whoops, right there. So as Daphne said, for those of you who are listening in but would like to be registered so that you can get the certificate of attendance, so to speak, if you'll just email that particular email, communications@gedtestingservice.com, with your name, you know, email, and just that brief note that you had attended but had not registered.
Yes, that would be very helpful.
Any other questions?
I think someone made a comment about, will you be sending us a follow-up email? And that follow-up email would be, if there's a, Daphne, is there something that goes out directly to everybody who was registered and attended today?
Not to my knowledge. You know, if people were looking for the materials, I think we'd probably be beating a dead horse in terms of telling people how to access the materials. You can either access it from the webinar interface, as Susan indicated, handouts, there are 3 of them, and download them and print them later. And if you didn't do that, that's okay, because it'll all be posted in the webinar archive. So 2 ways to access the material. One thing that I will say to the folks on this webinar, if you are not already registered, please make sure that you register for the in-session newsletter. That's the best way to be on top of the latest webinar information, as well as a host of information that you as instructors or your involvement with curriculum. The newsletter is designed for educators, and it's the place where we make sure that you're kept up to date with any of the new developments that will impact what you're doing in the classroom. So if you are not an in-session subscriber, please take the time to subscribe to in-session. And you will absolutely, without question, know when the next webinars and what topics will be covered.
And please, right now, the email, if you were not registered for today, is on the screen right now, communications@gedtestingservice.com.
And also keep in mind that when the materials are posted online, as Daphne was talking about, when those are posted, you can print off the certificate at that point if it hasn't been automatically received. So just keep that in mind as you're going through. Yeah. So I think having said that, Bonnie, we're about to, we're very close to the 5 o'clock hour here on the East Coast. And if there's anything else we need to cover, Daphne, Debbie?
Well, I just want to thank everybody for taking the time to be with us this afternoon and to have been as lively an audience as we could have hoped for. And please do understand that, you know, you do a delicate balancing act in the classroom with the materials, and exposure and getting students to actually see and interact with the material, which is for most of us a big departure from how we may have been instructed in school. But as far as science is concerned, and as far as data is concerned, being able to expose students to the big ideas is really critical. You know, long gone, thank goodness, are the days of having to memorize the periodic table. So, you know, keep that in mind as you use the resources we have available on the website to help direct what you do in the classroom. And thanks for being with us. Debbie?
And this is Debbie, and I'll make it short and sweet. Thank you so much. It's been a pleasure to spend the last hour and a half with you. Bye-bye.
Thank you, everyone. On behalf of Bonnie and myself, I'd just like to say thank you for being with us, and we look forward to, as Bonnie says it in quotes, seeing you in October. So take care, and we'll see you later. Have a great afternoon.
Bye.